This video is on the objective find and interpret the correlation coefficient. Alright, this is the second video on this objective. Hopefully you've seen the first one. It's pretty long. There was a lot in there where I went over some instruction, and what we're doing here is determining if the correlation coefficient, right, the value of this r, is significant or not. Right? We're running basically a hypothesis test. And we'll find critical values for r with so many degrees of freedom, and determine if our test statistic, our sample r, if it's between the critical values, that means it's too close to 0, and we would not reject the null hypothesis that r is 0, and say that there is no linear relationship. If the value of r is too close to 0, then we would conclude that there is probably not a strong linear relationship between the variables. If the test statistic, if r is outside the critical values, then r is far enough away from 0, so meaning close enough to 1 or close enough to -1, where then we would conclude that there is a strong linear relationship between x and y. And then in that case, we can use our best fit line as a good model for the data. In that first case, when we say there's no linear relationship, using the best fit line is not a good idea. It's not the best model for the data in the scatter plot. Alright, so let's take a look. So again, I hope you watched the first video. I did a lot of talking about this stuff. So again, if you want to see more about the topic too, click on more instruction, look at their videos, their notes, their examples. Hopefully those help. Alright, so say after collecting 20 data points, n equals 20, suppose you computed the correlation coefficient, this r, to be negative 0.85. So using the critical values table below, determine if the value of r is significant or not. Alright, so remember the value of r, the correlation coefficient, falls between -1 and +1. Right? These are possible values of r. And you got 0 in the middle here. Now we first find a number of degrees of freedom for this r distribution. And that's going to be n minus 2, right? The number of points minus 2. So this is 18 here, 20 minus 2. And alpha is always 5%. I know they don't mention it, but all these critical value tables are for a test with significance 5%. And the null hypothesis will be that there is no linear relationship. Basically r equals 0. No linear correlation between x and y. And the alternative hypothesis is that there is a linear relationship or a linear correlation. That r is not 0. Alright, so it's all hypothesis testing. So let's look for these critical values then. So again, 18 degrees of freedom. So I'm on this part here, right? Degrees of freedom, 18. Right next to it, the critical values, 1 plus 1 minus, are positive and negative, 0.444. So I'll mark those off on my number line here. So here's positive 0.444, right? That's one critical value, and then negative 0.444, right? The other critical value. Now we were told that for our sample, right, it said for our 20 sample points, we computed r to be negative 0.85, which would be here. Right, this would be the test statistic, r value of r. Well, you see how this is beyond, it's outside the critical values. So we'd reject the null hypothesis and say there is a linear relationship. Or we would say that this value of r is significant, right? R is significant here. Right? It's significantly close to -1 or 1, +1, to say that these two variables do have a linear relationship. And if we're saying that, if we conclude that they do have a linear relationship, then the best fit line, that least squares regression line, would be a good model to use to make predictions about our data. All right, so going back here, looking at the options, R is significant because it's between the critical values? No. It's significant because it's not between those critical values, right? It's outside. It's far enough away from 0 to where we can say with reasonable amount of certainty that x and y have some sort of linear relationship. And in this case, it would be a negative linear relationship, right? Because R is negative. So if I were to look at the scatter plot of these things, it would probably look like the data was going down as I move to the right. But we can say that. And that's it. All right, and if you remember from the first video, that is all they're asking for in these questions. Again, the first video was a little long because I talked a lot about the calculation of R and what R meant, along with whether or not R was significantly large or not. You know, is it significantly far enough away from 0 to where we can say the two variables have a linear relationship? All right. So again, hopefully watching me go over this real quick, looking at the more instruction when you need to, reading the answer explanations when they come up, right? I'm hoping all this stuff in my videos are helping you when you go about working on this on your own. And thank you very much for watching.